Hi and welcome. In this particular video, we are going to see about Armstrong numbers. It's a very basic concept. You just need to know about if, else, for loop, just very basic concepts, data type, variables, that's it. Fine. So, keeping this in mind, we are going to see how to solve this particular question. Okay, Armstrong number question. So let's read out the problem statement first. You will find this particular link in the description box below. Fine. So what are Armstrong numbers? So the question says that you are given a number n having x digits. So if the sum of all digits of number n to the power of x is equal to the number itself, then it's an Armstrong number. Now what is the meaning of this? So let's take some examples. Now if you see this, whenever we are going to solve a particular question, we are going to solve this using these 6 steps. No matter it's an easy question or a hard question. We need to first understand the problem statement. PS means problem statement understanding. Okay, line by line we are going to see it, we are going to understand it using sample test cases, etc. Then we are going to create our own test cases and analyze those test cases to get some logic out of it. Do not just depend on the sample test cases that are provided. Do not just create your logic using those test cases. Always create your own test cases and analyze them. Build some logic out of it. Then instead of implementing directly, write a proper algorithm in English, in normal English. Step-by-step algorithm so you understand which variable will be used, where it will be initialized, what will be its value. You will see it's a very interesting question. You will see, I will tell you the basic mistakes that the students make when they write some code. Okay, especially in the dry run, we will understand that if I just change the position of one line, okay, how big the impact is. Okay, it's very interesting. Now, the next is writing the algorithm, then implementation. If there is any issue in the implementation, debug it, or else dry run it. Okay, dry run you have to do whether your code is correct or not, especially in the learning phase. If you dry run when you are in the learning phase, you will have a very good understanding of the coding, of the implementing part. Okay, what is happening inside each line. It's a very important concept. Fine. So let's now deep dive into this particular question. The question says, for example, if n value is, let's say, 123. Okay, so that means x is 3. That we have 3 digits. So x value is 3. If n is, let's say, 371, then again x is 3. If n is 1634, then x is 4. Fine. The number of digits inside n is x. Now the question says, if we find out the power of each digit, okay, power of each digit, that is nothing but each digit to the power of x, and sum it. And if that number is equal to n, then this number is an Armstrong number. A bit confusing? Let's see. So let's suppose n value is 371. So what you need to do is 3 to the power of x plus 7 to the power of x plus 1 to the power of x. If this number is again equal to n, then n is an Armstrong number, else it is not. Here x value is nothing but 3. Okay, because we have 3 digits inside n, so x value is 3. So now we can say that 3 to the power of 3 plus 7 to the power of 3 plus 1 to the power of 3. Now next 3 cube is 3 cube is 27 plus 7 cube is 343 and 1 cube is 1. If you add these, we will definitely get 371. Fine. So from n371, we took each digit separately, okay, and we found out its power to x, each digit's power to x. We added them, and if the number came out to be n again, so therefore 371 is an Armstrong number. If you repeat this particular process, for example, let's say for 123, here x value is again 3. Okay, so we have to find each digit separately, find the cube of it because x value is 3, add the answers, add those cubes. If the value comes out to be 123 again, so 123 is an Armstrong number, else it is not an Armstrong number. So just pause the video and find out whether 123 is Armstrong or not. I hope you have paused and tried. So let's see. So 1 cube plus 2 cube plus 3 cube. So that comes out to be 1 plus 2 cube is 8 and 3 cube is 27. So this comes out to be, I think, 28 and 8, 36, which is obviously not equal to 123. So therefore 123 is not an Armstrong number. The same goes for another one, that is 1634. Here x value is 4. So what we will do? 1 to the power of 4 plus 6 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4. Okay, this term is an Armstrong number. Okay, you can find up to the power of 4 and then add them. Fine. So let's take a help of Google. 1 to the power of 4 plus 6 to the power of 4 plus 3 to the power of 4 plus 4 to the power of 4, and we get 1634 again. So yes, this number is an Armstrong number. So I hope now the problem statement is very clear. Okay, and we have taken some test cases as well to analyze it. Okay, to help us actually understand the problem statement first. But now using these test cases only, we'll try to build a particular logic out of it. Okay. So when we are saying that we are given a particular, and now we are starting with our building the logic using the test case analysis. Fine. So when we are saying that we have an n, let's say we have n373 or 371. Now this particular number, we need each digit of this number separately, because we need to find, okay, the cube of each digit. Especially in the case of 1634, again we need each digit separately, and we need to find the power of 4 for each digit. This is same for any number. If n value is, let's say, 1, 9, 2, 3, 4, okay, we have to find each digit separately and find the power of 5. The first thing is, how do we get each digit separately? And also in this particular question, if you read the question, you will find out that we do not have an x also. We just have n, do not have x. So that means we need to find x as well. So we need to find the number of digits. So first of all, find the number of digits. Find number of digits. That is nothing but x. And then get each digit separately and find its power. Add them, and finally if else. If the sum is equal to the original number, print yes, else print no. Fine. So how do we do this? How do we first of all find the number of each digit? Okay, sorry, the number in n, the number of digits in n. How do we find the number of digits in n? Well, so if you guys use Python, then maybe we will say, so we will simply get its length. Okay, because we can use string, we can get the length directly. Okay, but we will not go for that particular format. Okay, we'll go for normals, which can be used in all the four: C, C++, Java, Python. Okay, and that is using the loops and getting each digit separately and count the digits. Fine. So let's see how we can do that. So let's suppose n value is 1634. Now, do you know how to get the last digit of a number? Do you know how to do it? Get the last digit of a number. Which operator do we use for it? Come on, just think about it. Which operator do we use? We use modulus operator to get the last digit. So if I do 1634 mod 10. Okay, what is the meaning of a modulus operator? It gives us the remainder. Okay, so 1634 divided by 10 will give you 163 in integers. Correct? 0.4 will be there, but in integer data type, it will just give you 163. Okay, and the remainder will be 4. Correct? Remainder will be 4. Quotient is 163, remainder is 4. So the modular operator directly gives me 4. So whenever we use modular operator with 10, any number mod 10 will give you the last digit of that particular number. Fine. So if we have 225 and if we mod it with 10, we'll definitely get 5. We will always get the last digit of a number. Okay. So, okay, fine, sir. You told us how to find the last digit, but how to get each digit? So we'll use the same process of using mod, okay, by reducing the numbers. For example, we get 163 or 1634 mod 10. We get mod 10, we get 4 as the answer. Now we'll reduce this number to 163, which is very simple to do. Just think about it. Now 163 mod 10 will give me 3, that is the second last digit. So we'll reduce this number to 16. 16 mod 10 will give me 6, that is the third last digit. Okay, and we will reduce the number to 1, and 1 mod 10 will give you 1. That is now the last digit. fourth last digit. So we get each digit separately. Okay, in reverse we are getting it, but we are getting each digit separately. That is what we need. Now I can just find out the power of 4 to 4. 3 to the power of 4, 6 to the power of 4, 1 to the power of 4. Add all of it and I'm done. The question is solved. Fine. Now for those guys who know how to reduce it, great. Okay, you can try to code it out. For those guys who do not know how to do it, instead of using mod operator, which operator will we use? See, I've already told you 1634. Okay, integer data type. If I just simply divide it by 10, I will get 163. In integer data type, we do not get decimals as the answer in the division operator. Okay, we are using the floor division obviously. So what we will do is 1634 mod 10 will give you 4, and 1634 divided by 10 will give you 163. Now same 163 mod 10 will give you 3, and 163 divided by 10 will give you 16. Now the process repeats and we get each digit separately. So how to do this in a loop? So we can use while loop here. While our value of n is greater than 0. Okay, so remainder, that is nothing but the last digit is nothing but n mod 10. Okay, so this remainder is nothing but my last digit. Okay, and if I do n equals to n divided by 10, okay, I will get the number for the next iteration. Fine. Okay, so now for those guys who wants to try this particular code on your own, okay, try to do it on your own, because this particular loop will help you to count the number of digits as well, and this will also help you in getting each digit separately so that you can find the power and use if else after that. So if you want to try, you can pause this video, but here you can try to code on your own now. Okay, in whichever language you like, C, C++, Java or Python. Okay. For those guys who wants to watch this video further, for those who are not still getting how you will implement it, okay, let's move forward and see it. So now what we'll do. So first of all, what is the logic now? Let's write this particular logic down. Okay. Okay, we take n as the input. Fine. Now we need to find two things. Find the count of digits. Okay. And sum of the power of each digit. We need to find the count, we need to find the sum. So these two variables we need to initialize. Okay. Now to find the count and the sum, what we have to do? Let's see. First of all, if we find the count, we will run a loop while n is greater than 0. Fine. And count plus equals to 1. That is increment the value of count by 1, and n equals to n divided by 10. This particular thing will definitely give me the number of digits. But is it correct? It is correct, but is it correct for the whole code if I directly use n here? Let's see what is the issue. Now if I go and try to find the sum. Okay, and I write while n is greater than 10. Okay, and the above thing, we get the remainder part of it and everything. Will it work? Sorry, not n greater than 10, n greater than 0. Will it work? Come on, what do you guys think? Will it work? No, it will not work. Why it will not work? Because n value is changed. Now if you see here, if n value was 371, now at this particular point, n value is 371. Okay, n is greater than 0, yes, so count value will become 1. And n value will be divided by 10, so n value will become 37. Okay, so n value became 37. Okay, here 37. So count n is greater than 0, so count value will now become 2, and n equals to n divided by 10, n value will become 3. So n value became 3. Is 3 is still greater than 0, so count value will become 3, and n value will become 0. Now the loop will stop. So this is a dry run of this particular loop. Dry run means without using compiler, step by step what is happening inside this particular part of the code, I have wrote it down. Fine. So count value after this loop end is 3, but n becomes 0. So we cannot use this particular 373 anymore because n value has changed. So to ignore this particular thing, what we'll do is, instead of using n here, we'll be using something else. Fine. What we can do is we can create a temporary variable and we can store the value of n in that temporary variable. Fine. And we can use temporary variable instead of n. So it's the same thing because we are using the same value. Fine. Now, after this particular loop, temporary value will become 0. Okay, can we continue using n? Because do we need n after this particular point? Yes. After this loop ends, we need to compare if the sum value equal to n or not. But if we use n here, again we do n divided by 10, and again n value will change. So we cannot use n here. You understood? That is the meaning of writing algorithm properly. You understand each and every point which is needed, which is not needed. You just need to dry run properly. Fine. So now what you can do is, after this particular line, before this while loop starts, you can simply again initialize temp equals to n and then use temp here. Okay. Now you will get the remainder, you find the power, you find the sum, you add this particular power to the sum. After the loop ends, find if sum equal to n and done. This is how you can solve this question. Fine. So will you be able to implement this? So just try to implement this now. Fine. So I will be implementing this in all four languages: C, C++, Java, and Python. Okay. One thing that is remaining in this explanation, this whole explanation, is how to find the power. So you can use the power function, the inbuilt power function in your language. If you do not know how to use the power function or how to get power optimally, okay, we can simply, for now we can simply use for loop to find the power. Okay. So let's see the question. The question says that it has test cases. Fine, so test case loop will be required. Okay, if you do not know what is a test case loop, I will add a video link in the description. You can find it here as well. Okay. Now let's see. So in this particular question, you can see we need a test case loop. Oh, fine. So if I write a properly it down, okay, without using my handwriting. So we'll take t as input. Okay. Start the test case loop. Okay. Take n as input. Okay. Find x, that is the number of digits inside n. Okay, for that we also need temp variable. Okay, initialize it with n. Okay, we need the final, for final we need sum, initialize it with 0. And in the variable we need to find the power, so let's have a power variable. And if we initialize it with 0, or should we initialize it with 1? What do you think? It's a power variable. Power means if n value is 3, so 3 multiplied by 3 multiplied by 3, if x value is also 3. Correct? So multiplication is going on. So if there is a multiplication, should we initialize it with 0 or 1? We should initialize it with, obviously, 1. Okay, because multiplied by 0 is 0. You will find it out. Okay, moving forward, what we can do is we can simply write a loop, okay, where temp is greater than 0. Here, count plus equals to 1, that is find x. I can use the x variable, or if you are comfortable with count variable, find count of digits. So count, fine, and temp equals to temp divided by 10. Okay. Moving forward with this, we have the temp. Now temp will become 0. So again initialize it with n. Fine. Now while temp is greater than 0. Fine, you will find out the remainder. Okay, so we also need the remainder variable. So remainder becomes 0. Fine, remainder equals to remainder equals to temp mod 10. So you get the remainder at this particular point of time. Moving forward, after the remainder, we need to find the power. So if you are using inbuilt power methods, use those inbuilt power methods. Do remember to type convert them in C++, Java wherever required. Fine. In Python, you can directly use double asterisk. Fine. If you do not know how to use inbuilt power methods, you can directly use for loop for now. So if I equals to 1, I will simply run it till the count, and I will just use the power variable. Fine. So power equals to power multiplied by the remainder. That is the last digit. So I find the power in this way. Now sum equals to sum plus power. Fine. And after this loop ends, if sum equal to n, okay, print yes, else print no. Fine. Now do remember there is one more point. I have declared power equals to 1 here. So inside of this, power is not reinitializing. Okay, what effect it will have with the code, you will only be able to understand Okay, declaring power equals to 1 here, or every time initializing it here. What's the difference in this? Which is correct, which is wrong? You will only be able to understand this particular point if you dry run it. Without dry running, it is simply not possible to understand each and every point what is happening inside the code. Fine. So after this particular point, this is the whole algo. Okay. After this particular point, obviously you can use the inbuilt methods here. After this particular point, let's see one by one in all 4 languages, that is C, C++, Java, Python, the implementation of the same. Fine. So let's get started. So power here will be inside the loop. Okay. Why inside the loop and not outside the loop? If you just think about it, so let's suppose n value is 371. Okay. Now when we're inside this, we know that count value is 3. Fine. So now power becomes 1. And the remainder is nothing but 1. Now this loop runs. How this loop will run? I value equals to 1. Power value will be power into remainder. That is nothing but 1 itself. When I value equals to 2, 1 into 1 is again 1. When I value equals to 3, 1 into 1 is again 1. So power becomes 1. Sum becomes 1. Okay, here sum becomes 1. Now the loop runs again. Okay, after this particular point, there is one more line which I forgot to write. Okay, that is nothing but temp equals to. Otherwise, it will give us a time limit exceed because of the infinite loop. Temp equals to temp divided by 10. Now temp value will become nothing but here 37. So remainder will become nothing but 7. Power value is nothing but 1. Fine. After this loop ends, the power value will be 7 into 7 into 7, which is nothing but 343. And sum will become 343 plus 1. Okay, that is nothing but 344. Till here, good. No issues. No issues. Fine. Then power, this n temp will become 3. Remainder will become 3. Now there is an issue because power right now is 344. Now we are saying it to multiply 344 by 3. Okay, then the result by 3 and then the result by 3. Okay, we are not saying it to multiply 3 multiply by 3 multiply by 3, but 344 multiply by 3 cube. Now that is wrong. Okay, we need to find the cube or the power of x, power to x for each number separately. But here what is happening, understand that power of the previous number is affecting the next digit. Power of the previous digit is affecting the next digit. If we do not write this, just because we have written this inside the loop, every time power is reinitialized to 1 and each digit is getting the answer separately, which is what we need. Fine. Okay. Now let's try to code this out. Okay, I hope after this most of you will try to code on your own in your language. Okay, obviously you can definitely use your inbuilt methods if you like. Fine. Okay, let's get started with C first. Fine. So I've selected C. Let's start. In T, scanf percentile D ampersand T int n. Oh, sorry. First test this loop while T minus minus. Now int n scanf percentile D ampersand T ampersand n. What we need? We need a sum variable. We need a remainder variable. We need the count variable. Okay, power we will declare afterwards. Okay, so you can declare it here, but reinitialize every time. Fine. Okay. Now, first of all, we need count. So we need a temp variable as well. So temp equals to n. Fine, not 0, not 1, n. While temp is greater than 0, count plus equals to 1, temp equals to temp divided by 10. Okay, now I hope you are understanding what is happening inside each and every line. If not, please dry run, please dry run. Very important part, especially in the learning phase. Okay, now temp reinitialize to n. Fine, because temp becomes 0 after this loop, so we reinitialize to n because we need to run the loop again. So while temp is greater than 0, okay, here we are finding the remainder. So remainder equals to, before that power equals to 1 every time. So now remainder equals to temp divided mod 10. This will give me the last digit. Now for int I equals to 1, I less than equal to count I plus plus. Now there are various methods to use powers. Okay, there are very good methods to use power. You do not need to use a for loop to get a power. I know it, but I'm keeping it very simple for those students who only know about the loops instead of inbuilt methods. Okay. Now power equals to power into remainder. Fine. Now sum equals to sum plus power. Now if after this loop ends, if sum equal to power, we simply printf yes new line. Okay. Else we printf no new line. Fine. Okay, so let's run this particular code. Fine. So let's run this particular code. Okay, so it's giving me time limit exceed. See, I have not done time equals to time divided by 10. So it's giving me outside time limit exceed because of infinite loop. Let's run it again. Okay, so it's giving me a wrong answer because it should be yes for the second test case, but it's printing me a no. So what can be the issue? So the issue is sum equal to not power but n. Fine. Because we need to compare with the original number, not the power. So it should be n. Now let's run it again. So it's just basic issues, no issues. Okay, we got the answer. Let's submit it. If there is such issues you are not able to find it out, simply try run. If you are very good at try run, you will be able to see the issues very neatly, very quickly. Okay, if you know it is not printing me correct answer, so where can be the issues? So you can just directly go it. Afterwards, after a point where you have practice of dry run, but initially just dry run every code. Fine. So this has worked in C. Now let's go for the same in C++. Okay, so we are in C++. Let's start in T, C in T, while T minus minus, and int n, C in n. Which are the variables that we need? We need some variable. We need temp variable which will be initialized to n. Okay, temp will be initialized to n. We need power variable which will be reassigned the value of n inside every loop, inside that particular loop every time. And we also need one more variable. Remainder variable is needed. Okay, anything else? Count variable is needed. Yes. Fine. So while temp is greater than 0, okay, count of digits, count plus equals to 1, and temp equals to temp divided by 10. Fine. Now after this particular thing, what we can have is temp equals to n. Why? Because temp will become 0 after this loop, but we need the temp out in another loop as well. So temp equals to 0, the same thing repeats again. Now here power will become 1 every time. I already told you why. Now remainder equals to temp mod 10. Now to find the power, obviously you can use the inbuilt libraries. I am just keeping it very simple using loop. Okay, for those students who have just started and who knows only about basic things. So for int I equals to 1, I less than equal to count, I plus plus. Okay, power equals to power multiplied by remainder. So we will get the power now. Now sum equals to sum into sum plus power. Okay, so every time we get the power of each digit, we add it into the final sum. Now if this final sum is equal to the original number, that is n, okay, we simply print yes, capital, else no. Fine, see out, no. Just remember, output format says that yes and no should be in capital, so they have to be in capital. It should follow the output format exactly. Fine. Now let's run the loop. Anything is missing? Yeah, again the same thing. I'm missing temp equals to temp divided by 10. Fine. Let's run it. Okay. We get no and yes, no and yes. Let's submit the code. Okay. Obviously, you guys need to try run this to understand it. Internal working of here if you have not yet understood it. Okay, just practice dry run as much as possible. Okay, as much as possible, especially in the learning phase. So it got accepted. Fine. So this was C++. Let's get started with Java. So we are in Java now. So here, first we need to write scanner. Scanner sc equals to new scanner system.in. Okay, in t equals to sc.nextInt. Okay, you can use buffer reader as well. It's your choice to take the user input. While t minus minus is greater than 0, int n equals to sc.nextInt. Which are the variables that we require? We require int count equals to 0, remainder equals to 0, okay, temp equals to n, sum equals to 0, power equals to 1. Just remember that power will be initialized to 1, okay, every time in the loop. Fine. Will be assigned the value of 1. So now the next part is finding it. So file temp is greater than 0, find the value of count plus equals to 1. Now if temp equals count plus equals to 1, temp equals to 10 divided by 10. After this particular thing, temp value will become again n, because it becomes 0, we need temp again. So we reassign the value of n inside it. Now temp is greater than 0, power equals to 1 every time. Okay, remainder equals to temp mod 10. Now to get the power, you can definitely use the inbuilt method. Okay, I am just using a simple for loop for the beginners, fine, who do not know about the inbuilt method. So I equals to n, I temp, I equals to count, I plus plus. Okay, power equals to power multiplied by remainder. Fine. Now sum equals to sum plus power. That is nothing but getting each digit, finding the power of the digits, and then adding it to the sum. If after this particular loop ends, if sum equal to the original number, you simply need to print system dot out dot println. You need to print yes in capital because of the output format. Output format says yes should be in capital, so it should be in capital. Else we need to print no. Fine. So let's run the code and see the output now. Fine. Okay. I think there is an issue here for time limit exceed because I forgot this temp equals to 10 divided by 10. Run it. Okay, because of this it will cause an infinite loop. Okay, temp value will never change, so it will cause an infinite loop, causing time limit exceed. And now this is fixed. Let's see if there is any other error or not. So it runs successfully. We get no and yes as the outputs. Okay, we do not need to use /n here because we are using println, so it gives new line automatically. Now let's just submit the code. So always dry run it. Okay, always dry run the code as much as possible, no matter you find it easy, hard, or anything. Fine, especially in the learning phase, to get a pretty good understanding of what is happening inside the code line by line. Fine. So it got accepted. Okay, so this was in Java. Let's see the code for Python. So now let's write the code for Python. So take t as the input. Okay, int input, converting into integer. Okay, while t is greater than 0. Okay, t equals to t minus 1. Now n equals to int input, converting into integer. Now you can directly use the length method or the while loop, your choice. Fine. So we need a count variable, so count equals to 0. Count equals to 0. Okay, remainder equals to 0. temp equals to n. Fine. Sum equals to 0. Okay, we cannot use sum as it's a keyword. It's a function. So let's have the value of addition equals to 0. Okay, power equals to 1. Power will be 1 every time in the loop as well. So we'll see that. So while temp is greater than 0, count plus equals to 1, temp equals to temp divided by 10. So this same approach will be used in the reversing the number and so on. So you can do this approach in Python as well. Now temp value will be initialized to n. The reason being temp value becomes 0, we need it in another loop as well. So temp is greater than 0 again. We found the count. Power equals to 1 first. Remainder equals to 10 mod 10. Fine. Okay, 10 double divided by 10. Okay, integer division. Then here 4 I in range of 1 to count plus 1. Okay, exactly count will go. What we need to do is we need to get the power. Okay, in Python it is not very much required to do loops as in other languages, because other languages are inbuilt method, but Python directly can go for power equals to power multiply remainder. It has a variable for exponent. It has an operator for exponent. Okay, so addition equals to addition plus power. Fine. After the loop ends, if addition equal to n, in that case simply print yes. Okay, else print no. Fine. Anything else? Yes, I forgot this. Temp equals to temp divided by 10. Fine. Let's run the code now. Okay, there is a compilation error. Okay, addition. What's the error? Invalid syntax if addition equals to n. Okay, I forgot to write a column here. Fine. Now let's run it. Again. Else, column. Fine. Okay, it ran successfully, but it is not giving me a correct answer. Okay, it is giving me no and no. So let's see why it is giving me a no and no for both of the cases. Let's try run this out. So count value, temp value, find power 1 temp, power equals to power to the power of, okay, I think this is not correct from my end. Okay, sorry for this. I think this should be remainder to the power, not power to the remainder. Okay, so I can directly write here that is nothing but remainder to the count. Fine. So in this case, I do not actually require power. So remainder to the power of count. So digit to the power of count. It's direct. We do not use loop, so I got confused in this. So it's direct. Okay, we do not need to use power in Python. Okay, if you want, you can practice it for the loop with the method I explained. But since we directly have an operator, so we can directly add remainder to the power of count. Fine. So let's run this out. So now it's giving me a correct answer. Okay. Again, I do not need this lesson here. It automatically gives me a new line. Let's submit the code. So yeah, the code is submitted. Okay. So this was the implementation in Python. So we have seen all 4 implementations. So this was all about Armstrong number. Fine. So thank you so much for this video. If you like this particular video, please subscribe to our channel, like it, share it with your friends. If you want more such videos, okay, just comment the topic in the comment box. Fine. Thank you so much. Bye bye.